Hello and welcome. In this lesson, we will talk about the perimeter and area of various geometric shapes. So first we're going to take a look at the shapes and the respective formulas. So we're starting off with a rectangle. A rectangle has four sides, two sets of parallel and in the meantime equal sides, and a 90-degree angle. The perimeter of it is the two lengths, L plus L, and the two widths, W plus W. In a simplified form is double of length and width. The area of the rectangle is the product of length and width. The second shape is that of a parallelogram. A parallelogram, just like a rectangle, has four sides, two sets of parallel sides, and this is the second set of parallel sides, and it doesn't have a 90-degree angle like the rectangle does. The perimeter of parallelogram is the lengths of the two bases, B plus B, and the lengths of these two sides, which we are calling C in this case. In a simplified form is double of B plus C. The area of the parallelogram is the product of the base with the height, which is a perpendicular drawn between the two parallel sides. Next is the shape of a triangle, which has three sides, lengths A, B, and C as indicated, where A is different than B, different than C, not necessarily equal. The perimeter will be the sum of the lengths of the sides, and the area will be base times height, and that will be divided by 2. So you can write the area of a triangle as base times height divided by 2, or 1/2 of the product of base times height. I prefer to use this formula instead. The next shape is that of a trapezoid. A trapezoid also has four sides, just like a rectangle and a parallelogram. Just like a parallelogram, it has a set of two parallel sides. These are called the bases of the trapezoid. We usually indicate them by letters A and B. And it also has a set of two sides which are not parallel to each other. The perimeter will be equal to the lengths of each side as indicated by letters A, B, C, and D. When it comes to the area of a trapezoid, we have an interesting formula here. It will always be the sum of the two bases. Remember, the bases are the two sides that are parallel to each other. That will be multiplied by the height and then divided by 2. The way I like to look at it is as the average of the bases, A plus B divided by 2, and then multiplied by the height. So another version of the formula is 1/2 of A plus B times H, where H is the height. My favorite formula always is when we express the formula or write the formula as a single term rather than factoring the coefficient. But it's the same thing, same idea. So the next shape is that of a circle. We're all familiar with the circular shapes. The only measurement actually we need to draw this specific circle is the radius. Now we say that the circumference, which is the length of the line that forms the circle, it's also known by the word perimeter or circumference for the circle, is equal to 2 pi r. Now, because 2 times r equals the diameter, then we can express the circumference of a circle by using the formula C equals pi d. So this is a formula we use more commonly, 2 pi r, but an easy to use formula would be pi times d. Now the area of the circle is a equals pi r squared. So what we're going to do now is we're going to use all these formulas in various shapes to solve different problems. So we're starting with example 1. First, we want to identify the shape because that will help us figure out what formulas to use in order to find the area and the perimeter of each shape. So as you can see in here, we have a triangular shape. And what we're trying to do here is find the area and the perimeter. I'm going to start off with the area. And then I will find the perimeter on the other side. And why not write in here that we have a triangle? So since we're finding the area of a triangle, then we'll write area of a triangle equals base times height divided by 2. And now we have to examine the shape and check and see what's the base and what's the height in this particular triangle. So as you can see in here, you see this little square, which will always indicate that the sides are perpendicular to each other, which tells us that this must be the height and then this must be the base. And I like to show this on the diagram because it makes communicating the solution better to anyone, to your teacher, on a test, to your friends, and most importantly to yourself. So it's always a good habit to be able to explain things clearly and articulate them clearly. Now, the base is 9, the height is 6.1 divided by 2. And I'm using my calculator here on the side to perform this division. So we have 9 times 6.1 divided by 2, which is 27.45. And that would be the area of the triangle. Now remember one last thing, very important, unit measurements. Since the lengths are measured in meters, then the area is measured in meters, but because it's area, squared. And I like to box my answers usually. So that's done. Now we are going to move on to the perimeter now. So for the perimeter, we're going to say that the perimeter of this triangle would be equal to the sum of the lengths of the sides of this triangle. Now, to communicate the solution better, I usually like to give a name to each side. For side lengths, usually we use lowercase letters. And since I have used B, then I'm going to use here C for this side. I'll make this look better. All right, so perimeter is A plus B plus C, or 8.5 plus 6.8 plus 9. Perimeter equals plus 15.8 there, 24.3. Think about the unit measurements. We're measuring length, so meters. And done. Now moving on to the next example. We have to identify the shape first and then area and perimeter. So as you see here, we have the shape of a rectangle. And I'm going to write this down in here. And I've seen this somewhere actually. A different way of spelling rectangle is rectangle. I didn't make this up, actually. I read it somewhere. Okay, so now we're going to find the area and the perimeter. So I'll write area here. It's important how we organize the information because it becomes a habit. And it's a good habit, actually, to have in order describing the solutions correctly and organizing the solutions and writing things in order. Now, I'm going to get started with the area. Since we're talking about the area of a rectangle, we don't normally write the shape or the symbol for the rectangle. Usually for triangles we do. Not so much for rectangles, but I'm going to draw a cute little rectangle here. So the area of it is length times width according to the formula sheet. You can always refer to them, and they come naturally, obviously, with practice. And length is 6 centimeters according to our diagram, and width is 4.8. And 6 times 4.8 is equal to 28.8. That's area, everyone, and area of a rectangle. Now you have to think of the unit measurements. So since you're measuring the lengths both by centimeters, then you have to use centimeters. And because we're finding area, it has to be centimeters squared. And right now I'll say that I'm done with this answer. Now moving on to perimeter, we're going to say that the perimeter of this rectangle is double of length plus width. So that's double of 6 and 4.8, or double 10.8. So that would be 21.6 perimeter. So for perimeter, which is sum of lengths, we're using the centimeters as unit measurements. And here we go. This would be the perimeter. Now moving on to the next shape, we have a circle. So we say that I'm going to try to actually color the area of it a little bit. So I'm going to find the area and the perimeter. Remember that both area and the perimeter of a circle have some special formulas. Try to memorize the formulas. With practice, they will come easier to you, but it's always good to memorize. True that we can always refer to the notes or the book, but forcing our brain to memorize things, it's a very good drill for it. So the area of a circle is pi r squared. The radius here is given to be 3.5 decimeters. And we know that pi is just a number in the calculator. And if you look at your calculator, it looks just like this, right? And use the calculator to find the product, pi r squared. So to get the most accurate answer, I type pi in the calculator. But if you feel more comfortable substituting it by a number, you can also replace pi by 3.14 because that is its approximate numerical value. So either way, so for now I'm going to use pi on my calculator, which is pi times 3.5 squared in here, and I got 38.5. That's the area. And since the radius, which we used in measuring the area, is measured in decimeters, then area will be expressed in decimeters. And because area is measured in unit squares, so that would be decimeter squared. And voila, that's the area. Now, moving on to the perimeter, again, we're going to use the formula for the perimeter this time, 2 pi r. Now, the perimeter or the circumference is equal to 2 times, again, you can write 3.14 if you wish, or you can use pi directly from the calculator. I prefer to use pi because it gives a more accurate answer. And then you execute the product in the calculator in one step. So you go 2 times 3.14 times 3.5. So here we go, 2 times pi times 3.5. I got 21.99. So I will be rounding this to 22.0. And this will be in decimeters. Remember, circumference is length, so it's not unit squared. And voila, we're done with the circumference. Moving on to the next example, we have the shape of a trapezoid. This time the measurements are not given on the diagram, so it will be our job to put all the numbers on the diagram, and it makes it a lot easier when we put the numbers on the diagram rather than having them given in the problem. So when we put together numbers and the diagram, everything makes a lot more sense. So let's read together and put the numbers on the diagram accordingly. So we have the length AE, 3 centimeters. So this is A, this is E, this is AE, and that's 3 centimeters. Now the length BC is 7 centimeters. This is B, this is C, and that is 7 centimeters. So I'll write 7 centimeters here. Next, we have the length AD. AD, this is A, this is D, this is AD, 4 centimeters. And I guess that we kind of get the idea now. So this is DC 3.5, so that's DC. And then we'll write 3.5 centimeters here. And here goes AB. So here's A and here is B, 5 centimeters. And now we have everything. Now we need to find the area and the perimeter of the trapezoid. So I'm going to start with the area first. So the area of a trapezoid, you can either write the trapezoid. Another favorite way would be by simply writing the name of the trapezoid. So area of the trapezoid is called A, B, C, D, right? In our case. So I can write A, B, C, D here is equal to, and here we will need to use the names of the base. We have 2 bases, one is bigger and one is smaller. So the bigger base is BC, the smaller base is AD. So you add the 2 bases and then you divide them by 2 because we take the average of the bases and then multiply by the height. And the height is AE. Now substitute. BC is 7, AD is 4, AE is 3, and all this divided by 2. So we'll say that the area of ABCD equals, so we have 7 times 4, 28, divide 28 by 2, 14, and multiply 14 by 3, and we get 42 units. And the units are measured here in centimeters. We are measuring area, so centimeters squared. Let's move on to the perimeter. So I will say that the perimeter would be equal to the lengths of all the sides. So let's take a look at what sides we have in here. I like to start off by writing a formula always. Obviously, you can just add the numbers, right? So without having to write a formal formula. But since we're explaining things, why not? So that would be A, D, D, C, C, B, and A, B. Or you can add them as A, B, B, C, C, D, D, A if we want to go in alphabetical order. So A, B plus B, C plus C, D plus D, A. So the lengths here are 5 and 7 and 3.5 and 4. And use the calculator to execute this addition in one step. So that would be 5 plus 7, 12, plus 4, 16, plus 3, 19.5. Now that would be in centimeters. It's perimeter, so it's one dimensional, so we don't need to write square. All right, so we're moving on to the next example, and this is our last example. Now in this example, we have a parallelogram. Again, we are in a similar situation as in the trapezoid before. So we are given the lengths in the problem, but we don't know. We haven't actually put them on the diagram. So let's do this together. We are given FJ. So FJ seems to be the height of this parallelogram. So that's 7 centimeters. We are given IH, so here's I and here's H, that's 12 centimeters. Okay, and sometimes when I want to indicate that I'm talking about the length of this side, IH, then I draw an arrow at the bottom to indicate that. And the reason why is because as you can see in here, we have kind of two lengths. We have IJ and we have JH. And if we were to just put the 12 somewhere in here, it will be confusing to understand which one is 12th, right? So is it this side? Is it the whole thing? And that can be confusing to the people who read your work, and it can be confusing to you too, right? So especially when we are in a rush and trying to complete an assignment. So anyways, the next side, GH, would be this one here. And that would be 5 centimeters. And I want to bring your attention here to these little lines. As you can see here, we have arrows on these two sides. The reason why we see an arrow on each side is to indicate that these two are parallel. And on the other two sides, so FI and GH, we have two arrows in each, and they serve as a symbol to indicate that these two sides are parallel to each other. So I'm going to get started with the perimeter first, the area first, sorry, and then the perimeter. So the area of this parallelogram, which is called FGHI, is equal to base times height. And we're going to take a look at what we can call base and height in here. So it looks like this can serve as the base. And the reason why you choose this base is because you are given the perpendicular to it, the length of the perpendicular to it, which means we can use this as the height of it. So that would be the height. Substitute, and then we have 12 times 7. And the area would equal 84. We're using centimeters, and since it is area squared, and voila. The next question or the next part of the problem here would be finding the perimeter. Now, notice that we're only given 3 lengths. And for the perimeter, we're going to need all the lengths here in this parallelogram. Recall that in a parallelogram, the two sides or the two sets of sides will have equal lengths respectively, which makes this side 5 centimeters and this one 12 centimeters. So we're going to say that the perimeter equals 12 plus 12 plus 5 plus 5. And I'm going to say 24 plus 10 or 34 centimeters. And obviously, we can write the formula if you wish, right? Before we start, so perimeter is FG plus FI plus IH plus HG, right? And then substitute. So perimeter is 34 centimeters. And this is the end of this problem. All right, so this was today's lesson, and what we did here was, what we did in this lesson was find the perimeter and areas of various 2D shapes as we are preparing to put this to work and use them in finding the areas of 3D shapes in the coming lessons. So thank you for listening, everyone, and I hope everything made sense. Bye for now.